So this is assignment 6. The objective is to design a string matching algorithm for whiles and conjugates. So firstly, to build the program, this is the first thing I did. I introduced a small helper function to determine whether a character is while or not. So this is just easily being checked in this in this tuple function. And then in order to count the number of the whiles in the prefix, in the substring, and the suffix, actually the algorithm is pretty simple because we are not matching the full string inside. We're matching whether it's one or another. So it's like a binary match. We only need to go one run from the beginning to the end, and every time if we for example, if we want to count the whiles, so we start matching from the beginning, then every time we find out there is a mismatch, we start counting again. And in this algorithm, there are two counters. The first one is P. P is here to marking the starting point of this current count. And then I'm using I to loop through the full string. And anytime it is a different character of the different group of the character, then I stop here, I compare with P and make sure how long the current substring is. And then depends on the position of P and I know whether I'm currently a prefix or a suffix. So a suffix. Then if it's neither of them, then I'm a substring, or better way, prefix and suffix are also substring. So through this algorithm, I can get the three numbers by one run from the beginning to the end. So that will be the count whiles. Count conjugate is the same thing. So the only difference is instead of checking if the current character is not a vowel, I check if the current character is a vowel. That is this second algorithm. And in order to get the word with the longest prefix or suffix from a list, so here is what I did. I define a new function called words vowel, and it takes a list as an input argument. And so what it did is first, um, uh, yeah. So first, this line 37 and 38 is just to eliminate all of the duplicate words in this as list because it do not provide any new information. And for any of them running, then I build all of this initialized data structure to store the current max and a current max number and the current list. And then I just loop through the newly constructed list. And for any of them, I use the function I built before to count the vowels of the current word. But before doing that, I'm also converting the current word into a lowercase letter. This is to save this to save the computational effort of the first is well function. Okay, so then I continue moving on. If for any of the word I compare with the current max, then if it is larger than the current max, I clear the list and add the new one. If it's not, I just simply append. If it equals to the current max, I simply append to the uh, append new word to the list. So that will be the full algorithm for the word vowels. Similarly, the second, the word conjugate is almost the same as the vowels. So this is two lists that I use to check the function. The first one is simple one. You only have a few words. Second one is to open the text file given by this given by this assignment and read every word from the test file, remove the pre and append empty strings, and then I use the functions to calculate the longest vowels and the longest conjugate. And this is to demonstrate. So after running pre-list one way, pre-list 1C, this is the longest vowel and conjugate for the first list. Is the one way, sublist 1C, and sublist one way, sublist 1C. So that's for the first simple word list, and for the file, this is what I computed. This is a three vowel, three lists when I counting the vowels, and sublist to say, sublist to say. These are the three lists when I counting the conjugate. So this is my assignment 7. Sorry, assignment 6.